Okay, Anna. So I have here um, two squares, and we'll say that there's 1 liter by 1 liter by 1 liter. So here's your dry air, here's your water vapor. Now, the numbers that I gave you are approximate numbers, but we said dry air has a mass of 1.3 grams for every 1 liter. Whereas water vapor, I gave you a number that was 4.8, but it was milligrams per liter. So if we convert that into grams per liter, you can see how much lighter water vapor will be if we had a liter of it versus that dry air. It's about, let's see, 1.3 divided by 0.0048. That's about 270 times heavier, more massive than the water vapor. And one of the reasons for that is chemistry. What do we know about dry air? Most of dry air is N2, which is a fairly small molecule, but if we compare it to oxygen, they're about the same. They're right next to each other on the periodic table. So dry air is mostly those two molecules, whereas water vapor is going to have a lot of H2O in it. Well, it'll have one oxygen molecule, which will be comparable to one of those, but hydrogen is incredibly light. It is the lightest element on the periodic table. So this molecule, if they're the same number of molecules per volume, this molecule is going to be so much lighter than these two molecules. So, of course, the mass of this, maybe you'll have some oxygen molecules and some nitrogen molecules in there as well, but you'll have a lot of water molecules that will take up space and displace the oxygen and the nitrogen. So, much lighter molecule if this is also a gas compared to these two. So, that's one of the reasons why our water vapor is so light. The second thing I wanted you to think about is acceleration due to gravity. So if we have gravity holding this air down, well, we'd have to convert this right here into kilograms because I want to use 9.8 meters over a second squared, and I want a force. So I'd convert this. I'd move the decimal place over 3 times, so I have 0.0013 kilograms, and I'm going to multiply that. So 0.0013 times 9.8, and that would be a force because kilograms meters over second squared is a Newton. So the force of 0.127 newtons would be pulling down due to gravity because of that mass. Whereas if I do the same thing over here, let's convert this 0.0048 grams. So again, I'm going to move it over 3 spots to the left. So I've got 0, I'm going to go 1, 2, 3, and then another 1, 2, 4, 8, and that's going to be now in kilograms. And I'm going to multiply this time by the mass, by our mass times acceleration due to gravity, 9.8 or 9.81. I'm going to keep it simple, just make it 9.8 over second squared, put this over 1. Now we'll multiply that number, 1, 2, 3, 4, 5, 4, 8, times 9.8. So I'm going to put this one in scientific notation because it is so small. So 4.7 times 10 to the negative fifth newtons. So based on the mass that's in this 1 liter volume, that would be the force due to gravity pulling down. Whereas, let's put this in the scientific notation too then. 1.27 times 10 to the negative second newtons. Again, pulling down. Now let's say both of these are being pulled by gravity, and I explained to you the buoyant force. And if the buoyant force is equal and opposite, let me make that a different color. Let's go this maroon. All right, and that's the buoyant force. That would be going up at 4.7 times 10 to the negative fifth newtons. Then this 1 liter of water vapor doesn't go anywhere. So if we can actually calculate or assume if gravity is pulling on this mass in this 1 liter, and the buoyancy is the same. This water vapor isn't going up because of buoyancy. It's not going down because of gravity. It is just staying in place. Then we figured out the buoyant force. And we could do the same thing here. The buoyant force, if this dry air is not going anywhere, has to be equal and opposite of our gravity force or gravitational force, which is 2.7 times 10 to the negative second, and that will be newtons as well, right? All because we figured out the mass inside this 1 liter. And remember, we had to convert it into kilograms. So maybe you want to use this. It's really up to you. I think it's kind of cool. We assume lighter air moves up through, think of a hot air balloon, moves up through the air column. Why? Because of this buoyant force that we don't really talk about. We haven't talked about this year, but it is kind of cool. So equal and opposite. I think this would be possibly a great potential choice for you for your second calculation. All right. Hope that helped. Let me know if you have any questions.